Hi everyone, this is the third and last video about permutations for today. I just want to start off with, before we do the repetition thing, I want to start off with just a quick example problem of a word problem dealing with permutations and how we might do this. Okay, so the question is this: if I have a 4-digit code that I have to type in to like unlock something, okay, all digits here, all digits, no letters or anything, how many possible passcodes exist for that? You know, if I was just going to try each one to try to break the lock, how many do I need to have to be able to type in? Okay, so how many exist? The easiest way to do this is to simply look, and by the way, order matters in this, okay, so we got to keep that in mind. But this would be a great example of a permutation problem, because me typing in 4321 as the possible passcode is drastically different than me typing 4231. I know it's not drastically different, but you know what? One of those might unlock it and the other one's not. So in other words, order matters, right? And that's going to be a big deal to us. That means it's a permutation problem. And so in order to do this problem, here's what I need to know. First of all, how many numbers do I have to choose between? I have 10 digits, right? 0 through 9. 10 digits, okay? And then the next question that I have to ask, sorry, my lights went off for a second. The next question I have to ask is it a permutation? Does order matter? And it does, okay? So as I write out NPR, I know that the N is 10. And then the last question is, how many of those digits do I really care about at any given time? And I have 1, 2, 3, 4 spots. And so I'm going to do 10 NPR 4. So on my calculator, I go 10, math menu, NPR 4, and I have 5,040 different possible combinations that I could type in here. So there's an example of a permutation problem and when you might use it and how you might use it. So hopefully that helps solidify the concepts from the previous video a little bit more. Now let's talk about permutations with repetition. See, sometimes if I asked you, like, okay, if I wanted to use the letters from the word I, for instance, and I said, how many different ways can I rearrange I to spell different words? Well, the problem is I have an E here and an E here, and what if I switch those two around? You know, because they're both E's, they're still going to spell I. And so as I go through and I count off the number of things, see, in the ABC example, for instance, okay, in the ABC example, all I had to do is said I have 3 letters, so it's 3 factorial. There's 6 ways that I can rearrange it, right? But here, when the E's are the same, that changes the problem, because now I can spell EYE, I can spell EEY. I could spell YEE. Could I spell anything else? If I flip the E's, you know, it's still YEE. And you know what? I don't even know if there's anything else. The problem is that this E and this E are the same, and that changes the pattern. And so what we do then is we do the same kind of thing here, where we say, okay, I had 3 factorial choices to begin with. That'd be 6, right? But now I'm going to divide out by the number of repeating choices, and I'm going to factorial that. Okay, so I have 2 letters the same, E's are the same, and because I have 2 of the same thing, I'm going to put 2 factorial on the bottom. 3 factorial is 3 times 2 times 1. 2 factorial is just the 2 times 1. I can see that these go away. I'm left with 3 possible choices, right? With the letter E, Y, E, I have 3 choices. They're right here. So how do we do it for a longer word? How about Mississippi, right? Well, first things first, I need to know how many different letters I have. I have an M, I have an I have an S, I, S, I, P, P, I, right? So I only have 4 unique letters there. That means that I'm going to do 4 factorial if they weren't repeating. But because there's repetition, here's what I need to do. I need to go for the M's. There's only 1 M, so I'm good there. But for the I's, I have 1, 2, 3, 4 I's. Wait a second here. What am I doing wrong? How many? I did this totally wrong. Ignore this. It's not 4 factorial. Ready? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 letters in this thing. It's 11 factorial on the top. I'm dumb? Sorry. Sorry about that. Okay? It's 11 factorial on the top because you have 11 individual letters. Now let's go look at the repeaters. How many M's do I have? Just 1, so I don't need to worry about it. It can go anywhere. But as far as the I's go, 1, 2, 3, 4 I's. As far as the S's go, I have 2 S's and 2 S's. That's 4 S's. And as far as the P's go, I have 2 P's. And so I would need to divide by 1 factorial, which is just 1. But then I also need to divide by 4 factorial for the i's. I need to divide by 4 factorial for the s's and 2 factorial for the p's. So I'm going to write this out longhand so you can see what it is. Okay, I want you to understand that it's not 4 times 4 is 16 times 2 is 32. That's not 32 factorial on the bottom. That is absolutely wrong. Okay, really what this is, if I wrote it out, would be 11 times 10 times 9 times 8 times 7 times 6 times 5, 3, 2, 1. There's 11 factorial on the top. On the bottom, I have 2 times, I'm going to go through 4 factorial. So it's 4, 3, 2, 1. And then another 4, 3, 2, 1. And then for 2, it's just 2, 1. And I'm going to try to reduce this as much as I can. Okay, so 2 and 1, those go away. Obviously, the 1s don't really matter, right? I have a 4 and a 3 here, and a 4 and a 3 here. Let's look around. How about the 8 and the 4? Those reduce to 2 over 1, so that's good. And now maybe this 2 goes away with that 2, so that's good. 3 times 2 is 6, so how about we'll get fancy here. See this 3 and 2? That's a 6. Cross that off and cross the 6 off. I'm left with nothing on the bottom. On the top I have 11 times 10 times 9 times 7 times 5. That looks like what's remaining, right? These 3 and this one here and this one here. So the answer would be then 11 times 10 times 9 times 7 times 5. There are 34,650 different ways that I can rearrange the letters in Mississippi to spell unique words. So that's a pretty long, complicated example, right? You know you can do that on your calculator if you're just smart about it. Ready? Let's do this on the calculator and get it the same way. I'm going to do 11, math menu, factorial, divided by, and here's the key, parentheses to group everything else in the denominator. 4 factorial times another 4 factorial times a 2 factorial. The parentheses are the key. If I forget the parentheses, then only the first thing is going to be in the denominator. Now I'm saying this entire chunk of stuff is in the denominator. And when I click that, 34,650. So hopefully that makes sense. That's repetition if you have something repeating. Okay, we need to pay attention to that. There's permutations. That should be enough to get you going so we can do the homework. And then tomorrow when we come back, we'll talk about what if order doesn't matter. What if I just need three like groups of 3 out of 10 people in my classroom? That's a different situation when order doesn't matter. That's called combinations. For now, we're worrying about when order does matter, and I'm going to stop talking.